Greetings, this is Unit 7, Module 1, Session 2. The name of this home connection is Conversion Tables. It's a 2-pager. Make sure you put your name and number at the top. Let's begin. You're going to complete the table below and record at least 2 mathematical observations about the rule and relationship between the measurement conversions. So it looks like they're turning meters into centimeters, or if you go this direction, you're turning centimeters into meters. Our basic understanding is that when it comes to meters, one of them would be the same as 100 centimeters. And if you've ever seen a meter stick, which looks about the same as a yardstick, you would see that on that meter stick, it's broken into 100 centimeters. You'll see 1 through 99, okay? So looks like in order for you to convert meters to centimeters, the easiest thing might be to notice that this has a 1, this has a 1, but this has 2 zeros, okay? And as we go through this chart, if I add 1 on this side, that would be the same as adding 100 on this side. You can also think of it, though, as just adding 2 zeros, which we kind of we've mentioned in previous lessons, I think. So 2 becomes 200. How about we do this 4 here? 4 becomes 400. Let's see, 7 right here becomes 700. You might as well get used to writing your units, right? There's nothing wrong with that. Centimeters, 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 centimeters. And then what happens if you work backwards on here? Well, I'm guessing we could just remove the zeros, because if we have 300 centimeters and we go to meters, we could divide by 100, but you could think of it as just getting rid of the zeros, so we would have 3 meters. This 500 would become 5. This 600 would become 6. And you can see that there's a nice pattern here where you go 100, 200, 300, 400, 500, 600. And here we're counting by ones. 1, 2, 3, 4, 5, 6, 7. So a little bit of review here. So what did you notice? I'm going to leave that up to you. What I noticed is that when you add 1 meter, you add 100 centimeters. Okay? And it wants you to record at least 2 mathematical observations. So think of another thing that you notice in there, okay? A very large bag of frozen vegetables weighs 64 ounces. How many pounds is this? Create a table to show your thinking. So here we have a table, and it points out for us that 16 ounces is the same as 1 pound. Okay? So if I'm going to go up, let's say, to 2 pounds, okay, and LB is the abbreviation for pounds, okay, then that on the other side, that would be the same as adding 16, okay? 16 plus 16 is 32, and then OZ, I know these kind of don't make the most sense, but ounces is OZ, and pounds is LB. Okay, that's just something you're going to have to learn and be okay with the weirdness. Now, we're trying to get to 64. We could keep going, which I'll show you. We'd go up another 1. We'd have 3 pounds, okay? And then if I go up again, I'm adding another, oops, I pressed a button. Shouldn't have pressed it. It would be the same as adding another 16. And you have lots of room over here. If adding that in your head is not pleasant, you could just pencil it in over the side and add it like that. 6 plus 2 is 8. 3 plus 1 is 4. Okay, so now I'm up to 48 ounces. Okay, and then I could just keep going. Our goal is to get, like we said, to 64 ounces. We want to know how many pounds that is. Okay, so here we go. I'm going to add another 1 here. So I've got 4 pounds. And then I'm going to go up another 1, which is the same as adding 16. I can just come right back over here, couldn't I? And just put another 16 down here and keep adding. 8 plus 6 is 14. Carry the 1. 1 plus 4 plus 1 is 6. So I have 64 ounces. And look, I'm there. So how many pounds is 64 ounces? 4 pounds. So that is my answer, 4 pounds. If you wanted to show your thinking in another way, which is what it says down here, I noticed a pattern that I was hoping to point out to you. And just because I kind of like looking for patterns, I noticed when I got to 32 that was half of 64. Okay, so what I was thinking in my brain was 32 is half of 64. And we're going for 4 pounds. So we're saying double 2 pounds equals 4. Now that's kind of, I didn't really use complete sentences, so if this doesn't make sense, hopefully I can point it out to you. 32 is half of 64. 64 was what we were looking for, right? So if I double the 32, I get 64. Well, we know 32 is 2 pounds, so if I double that 2 pounds, I get 4. So I could have maybe done that a little bit faster, but once again, it's noticing the patterns. So see, in this, your math homework is going to try to lead you to some really nice explanations. So keep that in your brainium, okay? Let's keep going. All right, looks like on this second page here, we're doing some tables with conversions. The first one says solve 6 feet 7 inches is how many inches? Well, let's remind ourselves that 1 foot, FT is foot, is 12 inches. Inches is IN. So what we need to remember in here is that we should probably start with the feet first and then add the inches on. Don't you agree? So in our brains, we're kind of setting up a mini ratio table. So 1 foot is 12 inches. I have 6 feet. Let's forget about the 7 inches for now and figure out how many feet 6 inches would be. Well, I'm going to take 6 times 12 to figure out how many inches are in 12 feet. And I know that is 72 inches. Now that I know that, I can add the 7 that I kind of forgot about there for a total of 79 inches. Okay, so you got to make sure you put it in the right box, though. I almost didn't. Okay, I'm going to do one more with you, okay, just so that we can do some yards. Yards are super important. 1 yard, YD is yard, is the same as 3 feet. Okay, so if you're trying to figure out, well, I have 1 yard here and 2 feet. Well, this 1 yard, look, I already did the conversion on it. This is 3 feet. Then I need to add these 2 more feet to it. So I've got 3 feet. And then I'm going to add my 2 feet that I kind of left off until the end for a total of 5 feet. Okay? Now, I'm going to look through these real quickly. This one I feel comfortable doing because you're going to use this. 30 feet is how many yards and how many feet? Ooh, that's going to be the opposite. You're going to have to do some dividing, okay, because there's 3 feet in a yard. So this is going to be a smaller number here, okay? 32 inches is how many feet? It's backwards again, and 8 feet 6 inches is, you're going to go only inches, so you'll have a bigger number here. So this, so the first box, the third box, and the last box are pretty much the same. I'm kind of interested in maybe doing this one up here, because we know that there's 3 feet in 1 yard, okay? So that means there would be 6 feet in 2 yards. And we could do a ratio table like that until we get to 30, couldn't we? Or I could say 30 divided, ooh, I'm struggling here. Boop, boop, boop. 30 divided by 3 is what? Okay, how many 3s fit in 30? Well, I kind of like doing, it's not secret math, but if you set up your division problem maybe like this, 30 divided by 3. And then if you're, sorry, didn't mean to get rid of that. You could say how many 3s fit in 3? Well, you'd say 1 perfectly, right? And then how many 3s fit in 0? None. So the answer would be 10. Okay, and that's actually going to be an even number, 10 yards and no feet remaining. Okay, because 10 times 3 is 30, isn't it? So that's a nice one. When you do it down here, I want you to make sure that you understand that there will be a remainder. So you're going to count by 12s, right? Count by 12s and get as close to this as possible. And then however many is left is your remaining inches. Okay. Sorry, it took me a while there. Draw a line from each statement on the left. Oops, I meant to get my arrow. To the multiplication equation on the right that matches. Then solve the equation. My sister is 4 feet tall. Her height in inches is 12 times as much as 4. Well, that would be true. If you're 4 feet tall and you're trying to figure out how many inches that is, you're going to take that 4 feet times 12. Well, which one is that? It looks like this one right here. So I'm going to draw an arrow, and then I need to solve 12 times 4. If you like doing the stacking, you could do it that way. 4 times 2 is 8. 4 times 1 is 4, so that answer is 48. Okay. If you know your 12s times tables, then you probably got that answer faster than I did. If your 2 by 1 is not amazing, then maybe you're interested in breaking the numbers apart. Like you could say 12 is made of 10 and 4. Or excuse me, I need to figure out life for a second. Here we go, 10 and 2. So I could take 10 times 4, 2 times 4, and then combine those. 10 times 4 is 40. 2 times 4 is 8. 40 plus 8 is 48. Okay? And I'm going to let you do those last 3 on your own. Okay? There are 5,280 feet in a mile. Write your own comparison statement to match this multiplication equation. Then solve the equation. Wow. So it says write your own comparison statement to match this multiplication equation. So my statement, or maybe it's talking about a story problem, could be I went running, and I'm going to pause this video so I can make this go faster. Give me 1 second. All right, so I went running 24 days this month. I ran 1 mile each of those days. How many feet is that? It's kind of a basic story problem, but that'll work. I see this, and it says solve it. Oh my goodness. Well, if it looks a little intimidating if I stack it, 5,280 times 24. Oh yeah, that's going to be some intense math. But I see something in my brain that I'm kind of wondering if you would try with me. In the last unit, we did so much halving and doubling. So if I set up my equation like this, and I double the miles, or the feet, and I cut the 24 in half. So if I cut this in half, I get a 12. Okay? If I cut it in half again, I get a 6. And that's my goal, is to get a single-digit number. Well, if I do that, then I have to double the 5,280 2 times. So if you want to do just adding it, you could get a 0 here, a 16, carry the 1, a 5, and then a 10. Ooh, that's a big number. It's kind of scary. But then we said we had to double it again. Why? Because if you cut it in half, you have to double and then double. It has to match, or else the equation will be wrong. So I'm going to add another 10,560 feet. Am I insane? Maybe. 21,120. You're like, wow, we don't do a whole lot of math that's that big. No, but this is going to be easier than this. If you are good at your multi-digit times multi-digit, then you're fine. If not, you're going to thank me when we do this. So I have 21,120 times 6. Oh my goodness. When you're taking a giant number times a single digit, it's just the same thing over and over. So let's do it. 6 times 0 is 0. 6 times 2 is 12. Carry the 1. 6 times 1 is 6. Plus 1 is 7. 6 times 1 is 6. 6 times 2 is 12. So my answer is 126,720 feet. Woo! So that is a big number. But I hope you will agree that doing our doubling and halving until we have a single-digit number is super beneficial. look for those patterns, okay? Thanks for your patience. Thanks for sticking with. If you have questions, make sure you talk to a math wizard so we can help you. Check you later.